5 times in the last 445 million years. This planet came within a rounding error of killing everything on it, and it never needed a monster to do it. A frozen ocean, poisoned air, and a burning sky. 3 mechanisms across 5 events, every one of them slower and stranger than anything with teeth. But the list you have heard your whole life is missing one, and I am holding it back until the end. First, all 5. What killed you, how long it took, and what it felt like from inside your own body. Every other video on this subject is an animal attack tour. You step off a time machine, something with a jaw like a bear trap finds you, and you are dead in 90 seconds. Fine. That is a fun way to spend a lunch break, and I have watched a dozen of them, but it misses the actual story, because the animals were never the dangerous part of the past. Animals kill you in minutes. The planet takes its time, and when the planet decides to clear the board, it does not use claws. It uses chemistry, temperature, and physics, and it does not care whether you're a trilobite or a person in a windbreaker. So here is the deal for the next half hour. 5 chapters, 1 for each of the big 5. In each one, you are standing there. No time machine, no rescue, just you and the mechanism. And keep a running tally, because by the time we get to the end, you are going to want to know which one I left off the list. Chapter 1. The End of the Ordovician. Cold, then drained. 445 million years back, almost nothing lived on land. Nothing with a spine, and certainly nothing that would one day become you. A few mosses and mats near wet ground, and that is about it. The entire show was in the water. Trilobites, brachiopods, sea scorpions the size of a golden retriever, reefs built by animals that no longer exist. Warm, shallow, tropical seas flooded the edges of the continents, and that is where the diversity was, for the same reason it is today. Sunlight reaches the bottom, the water stays warm, and rivers keep the nutrients coming. If you wanted to design a nursery for complex life, you would design a shelf sea, which is exactly why draining one is such an efficient way to end things. Then Gondwana drifted over the South Pole and froze. This is the only one of the big 5 that happened during an ice house. Every other extinction on this list is a heat story, in one form or another. This one is a cold story, and it works differently. When a supercontinent sits on a pole and ice sheets build up on it, that ice has to come from somewhere, and where it comes from is the ocean. Sea level fell by 50 to 100 meters. 80 meters is the figure cited most often. Now think about what a shelf sea is. It is a shallow apron of water over the edge of a continent, sometimes only tens of meters deep. Drop the ocean 80 meters and that apron stops being a sea and becomes mud, then dry ground, then nothing but weather. Roughly 85% of marine species were lost. That is the number that has been in the textbooks for decades. A more recent study out of South China, working from a much larger fossil dataset, puts the loss closer to 70%. I am giving you both numbers on purpose, because both are defensible, and I would rather you hear the range than a false precision. Even at the low end, this is the second worst extinction the planet has ever produced. Roughly twice as severe, by species lost, as the one that killed the dinosaurs. But the cold was only half of it, and not the deadly half. The extinction came in 2 pulses. Pulse 1 is the freeze and the drainage. Pulse 2 came when the ice melted. The ocean rushed back onto the shelves, and the climate whipsawed toward greenhouse warmth. Warm water holds less oxygen. Sudden warming stirs up nutrient-loaded deep water. The shelf seas that had just refilled went anoxic, and the survivors of the freeze suffocated in the thaw. What is wild is how fast that second pulse worked. Radioisotope dating of the boundary sections shows the second pulse, killing at a rate on the order of 70% of species per 100,000 years, against under 10% for the first pulse. Put those 2 rates side by side, and you get the real lesson of the Ordovician. It was the speed of the climate swing, more than its direction, that killed most of those animals. Now put yourself there, standing on a coastline, or, more honestly, on what used to be a coastline, because the sea has retreated kilometers out, and between you and the water is a plain of cracked mud and dead reef. The wind is coming off a continental ice sheet somewhere behind you, and it does not stop. There are no trees because trees have not been invented yet, which means nothing to burn, nothing to build with, and not even a hill worth the name to get behind. Your body does not have an oxygen problem here. The air is breathable. What your body has is a heat problem, and it has no way to solve it. This is what exposure does. First you shiver, which is your muscles burning fuel to make heat, and it works for a while. Then the shivering stops, which feels like relief, and is the opposite. Your fingers stop taking orders. Your thinking gets slow and slightly pleasant. Somewhere in there you sit down, and once you sit down on that mud in that wind, you are not getting up. Hours to a day. That is the Ordovician for a person. You were never drowned or eaten. You went cold on a coast that used to have an ocean in front of it. And the second pulse, the warm one, would not have helped you at all. You would just be cold beside a shoreline that suddenly smelled like a rotting tide pool, which, as it happens, is where the next chapter starts. Chapter 2. The Late Devonian. The water breathes out poison. By 372 million years ago, life has crawled onto land in a serious way. There are forests now, real ones. And in the water, this is the age of fishes, armored fish, lobe-finned fish, sharks that would look mostly like sharks to you. The reefs of the Devonian were the biggest reefs the planet has ever built. Thousands of kilometers of them thrown up by sponges and corals in warm, shallow seas. Then the reefs died outright. The corals of the Devonian were annihilated as reef buildings, and reef building of that kind did not come back for a very long stretch. The extinction hit warm, shallow water life the hardest, which is a strange signature. If the killer were an asteroid or a volcano, you would expect it to hit everything. Something was going wrong specifically in the shallows. The mechanism was the water itself. 2 words you should know, because they will come back in almost every chapter of this video. Anoxia, which is water with the oxygen gone, and euxinia, pronounced yok-sin-e-a, which is water where the oxygen is gone and hydrogen sulphide has taken its place. Anoxic water suffocates you. Euxinic water suffocates you and poisons you at the same time. In 2023, the team published a study in Nature built on 90 drill cores across the Bakken Shale, the rock formation under North Dakota and Saskatchewan that produces oil. What they found in those cores was a record of sulphide-rich water climbing, step by step, up out of the deep basin and into the shallow seas, over and over, and each of those steps lines up with a pulse of Devonian extinction. Their conclusion goes further than the Devonian. They argue hydrogen sulphide toxicity is a recurring killer across the full history of complex life. Remember that when we get to the Permian. So who poisoned the ocean? This is the part that stays with me. The best supported trigger is the trees. Deep-rooted vascular plants had just evolved. Roots broke rock apart, chemical weathering went up, and rivers started delivering a flood of nutrients to the sea that the sea had never seen before. Nutrients feed algae. Algal blooms die and sink. Bacteria eating that dead algae strip the oxygen out of the water, and, in the deep basins, start producing hydrogen sulphide. Dead zones spread, and sulfidic bottom water builds up. And when sea level shifts, that water comes up onto the shelf where the reefs live. The forests, in a real and traceable way, helped kill the ocean. Now for the part almost nobody tells you. There were 2 big Devonian pulses. Kelwasser, pronounced Kelvasser, around 372 million years back, is the pulse that killed the reefs. Hangenberg, pronounced Ha-Hangenberg, around 359 million years ago, did its worst work on land, and it is the weird one. Hangenberg is also the pulse that finished the placoderms, the armored fish that had ruled the water for tens of millions of years. So the age of fishes ended with its most famous fish gone. In 2020, John Marshall at the University of Southampton published on plant spores recovered from ancient lake sediments in East Greenland and Bolivia. Normal spores from these plants are covered in neat, even spines. The spores at the Hangenberg boundary are malformed. Spines crooked, clumped, wrong. That kind of damage is the fingerprint of ultraviolet radiation, and ultraviolet getting through means the ozone layer had failed. So you look for the volcano, because every other ozone collapse in this video comes with a giant eruption, and the mercury signal that marks those eruptions in the rock is missing. No volcano, the ozone layer thinned, the sun came through, and the plants on land got cooked without a single lava flow. Marshall's proposed mechanism is that rapid warming at the end of a glacial cycle drove more ozone-eating chemistry up into the stratosphere, which is a sentence worth reading twice. But that is the land. Your death is on the shore. You are standing at the edge of a warm, shallow sea at low tide. Something in the water has been off for weeks. Fish washing up, that sort of thing. Then a wind shift or a tide brings deeper water up onto the flat, and you smell it. Rotten eggs. Every human being alive would recognize that smell, because our noses are tuned to hydrogen sulphide at concentrations of a few parts per billion. It is one of the smells your body is built to flag, and this is what makes hydrogen sulphide a killer rather than a nuisance. As the concentration climbs, the smell goes away. The gas is still there. Your nose has stopped registering it. The receptors fatigue and shut down, and the warning system that just told you to leave goes silent at exactly the moment you most need it. So you stay. Your eyes begin to burn, your throat follows, and a heaviness settles into your chest that you might mistake for panic. At high enough concentrations, hydrogen sulphide interferes with the same cellular machinery cyanide does, and breathing stops. On a real Devonian shore, the concentrations coming off the water would have varied hour to hour, so you will not get a fake stopwatch from me here. It could be a long afternoon of getting sicker. It could be a few minutes at the wrong spot on the wrong tide. What matters is the shape of it. Air you cannot breathe next to the sea with the smell gone. That was 2 extinctions where the killer was water and cold. The next one used everything at once. Chapter 3. The End of the Permian. And this one is told as a clock. 252 million years ago, this planet came as close to sterile as it has been since complex life began. Up to 96% of marine species, about 70% of land vertebrate species. A 2022 review in Nature Reviews puts the marine range at 81 to 94%, and any figure inside that range would still make this the worst thing that has ever happened to life on Earth. It is the only mass extinction that took insects with it. Insects survived the asteroid. They did not survive this. The cause has a name and an address. The Siberian Traps, a large igneous province which is a polite geological term for a region where the crust cracked open and bled magma on a scale that has no living analogue. Dating work out of the Massachusetts Institute of Technology puts the start of explosive eruptions about 300,000 years before the extinction horizon. The total volume of magma erupted plus intruded underground is enough to bury the entire United States a kilometer deep. Roughly 2/3 of it came up before and during the extinction. You need to hear one thing about the way I am going to tell this next part. The end Permian extinction played out over tens of thousands of years. Nobody stood in one place and watched it happen start to finish. But I am going to compress it into a clock, hour 1 to month 6, because that is the only honest way to describe what it would feel like to be one body, in one place inside the worst stretch of it. The clock is a feeling, not a geologic timeline. Keep that distinction, and the rest of this chapter is fair. Hour 1. You are in the interior of Pangaea, in the tropics, and the sky to the north has been wrong for a while. Hazed rather than dark. The Siberian Traps are not one volcano. They are fissures, hundreds of kilometers long, and the magma coming out of them is passing through something on the way up. Cambrian salt beds, 2.5 kilometers thick, laid down when that part of the world was a drying inland sea. Heat those salts and they release methyl chloride and methyl bromide, and those are ozone-destroying compounds. Sulfur and carbon come out too, but the salt is the detail that gets left out. The eruption was pushing through a chemical stockpile that had been waiting 500 million years. Day 1. The rain has started, and it stings. Sulfur dioxide from the eruptions has come down as acid, and the acid rain that ended the Permian on land was not a metaphor. The collapse on land began tens to hundreds of thousands of years before the collapse in the sea, tied to acid rain, ozone depletion, and harsher seasons, so the forests were dying long before the fish were. If you were on land, you were early. Week 1. The sun feels wrong on your skin. Models of the ozone damage from those salt beds range from moderate depletion to near total collapse, and the rocks give a hint about which end we got. At the extinction horizon, in Russia, in China, in Norway, in South Africa, in India, the same thing turns up. 3 to 6% of fossil pollen grains are malformed, and spores that should have separated into 4 are stuck together in tetrads. Same damage, 5 continents, same layer. That is the ultraviolet fingerprint from the Devonian chapter, but this time with a volcano attached. Work published in 2023 went further and reported fossil pollen from the peak volcanic phase loaded with the plant equivalent of sunscreen, ultraviolet absorbing compounds the plants had ramped up. That last result is contested, and you should hold it loosely. The malformed pollen is not contested. Month 1. Now the heat arrives, and this is where the Permian stops being an eruption and becomes a climate. Global air temperature rose by as much as about 8 degrees Celsius. Ocean temperatures rose by nearly 10. And in the tropics where you are standing, it went further than that. A 2012 study in Science by Sun and colleagues, using oxygen isotopes from conodont teeth, put tropical sea surface temperatures approaching 40 degrees Celsius in the aftermath, and estimated the land itself in the equatorial belt at 50 to 60 degrees. That paper is disputed. It is also the reason a lot of people started taking the Permian seriously as a heat event and not just a poison event. Whatever the exact numbers, the equatorial belt became a dead zone, almost no fish, almost nothing growing, and it stayed that way for something like 5 million years. You need to understand what 40-degree water means for a body. Your core runs at 37. In air, you shed heat by sweating, which only works if the air can take the moisture, hot enough and humid enough, and it cannot. Your body has no cooling left. Your heart rate climbs, your kidneys start to shut down to save water, and your brain, which is the organ most sensitive to overheating, starts to misfire. Confusion first, then nothing. In the Permian tropics, standing still in the shade would have been enough. Month 3. You have moved to the coast because the interior is unlivable. Bad choice, but you did not have a good one. The ocean is doing 3 things at once, and each of them is its own extinction. It has gone anoxic and eugenic in most rock sections around the world from this time. So the Devonian killer is back, and now it is global. The ocean is acidifying because a large fraction of the carbon dioxide from the traps has dissolved into it, and shelled animals cannot build shells in acid. And the water is loaded with carbon dioxide itself, a condition called hypercapnia, which poisons animals directly by wrecking the acid balance of their blood. Net primary productivity in the ocean, the amount of new living stuff being made at the base of the food chain, is modeled as having fallen by around 40%. That is the ocean's food supply, cut nearly in half, on top of everything else. Month 6. The sky is still hazed and the rain still stings on the days it comes. The forests you remember are dead standing wood, and there are fungal spike layers in the rock from this time because when a whole planet's worth of trees dies at once, the fungi that eat dead wood have a very good few centuries. If you have survived this far, it is because you found high ground with cool nights, some water that has not gone bad, and something still growing, and there is nothing coming to end it, and there will not be for a very long time. That is the difference between the Permian and everything before it. The Ordovician was one mechanism, cold, then one more, thaw. In the Devonian, one mechanism, poisoned water with an ozone crisis on the side. The Permian was every mechanism in this video, running at the same time. Acid, ultraviolet, heat, hypoxia, sulphide, acidification, starvation. There was no single thing killing you. There was no direction to run. If this is the kind of deep time story you want more of, walk through slowly and honestly, with the disputed parts flagged, hit subscribe. It helps more than you would think, and it keeps this channel alive to make the next one. Because as far as the planet was concerned, it was not done with that recipe. It ran it again. Chapter 4. The End of the Triassic. The Mirror. 201.5 million years ago, about 76% of species died. Some estimates go up to 80. And if you have been paying attention, The next sentence is going to feel like déjà vu, and that is on purpose. The cause was a large igneous province, though this time the address was on the far side of Pangaea, the central Atlantic magmatic province, the volcanism of Pangaea itself splitting apart along the seam that would become the Atlantic Ocean. That activity is dated to an interval of about 620,000 years, with the first 40,000 years the most intense, and that first burst is what lines up with the extinction. Melt inclusion work, which is chemists reading tiny pockets of trapped magma inside the crystals, shows the carbon dioxide came out in pulses. Each pulse lasted a few centuries to a few thousand years, and each one was enough to warm the planet by around 2 degrees Celsius and acidify the ocean. Seawater acidity shifted by at least 0.3 units on the pH scale toward acid, and that is the largest shift detected anywhere in the last half-billion years. The result is a reef gap in the rock record. Reefs vanish from the fossil layers and take a long time to come back. 3 details that rarely make the cut. Fern spores at the boundary are abnormal, and this time the leading suspect is volcanic mercury poisoning rather than ultraviolet, because the mercury signal is present. If you have ever driven along the Hudson River across from Manhattan and looked up at the Palisades, that dark cliff is this eruption. It is a piece of that same magmatic province, and it represents less than 0.2% of the total magma volume. And in 2024, a team publishing in the Proceedings of the National Academy of Sciences argued that on land, the primary killer was the opposite of what you would expect. Cold, in the form of volcanic winters rather than heat, sulfate aerosols from the first pulses, injected fast enough to drop temperatures hard for years at a stretch. Cold snaps, then heat. The mechanism is still argued over, and I would not pretend otherwise. Now the human version, and I am going to keep it short, because the horror of this chapter is recognition rather than information. You are standing in the tropics of a supercontinent. The sky to one side has gone hazed. The rain stings. The sun feels wrong. Somewhere along a coastline, the shallows are going still and starting to stink. You know this. You have already lived through this 1 chapter ago. It is the Permian in smaller print, and the worst thing about it is that you can see the entire shape of it coming from the first day, and there is nothing to do with that knowledge. 50 million years after the closest call in the history of life, the same Fisher and poison recipe came back and took 3/4 of everything again. Whatever your death is here, it is a death you have already rehearsed. But the next one you have not. Chapter 5. The End of the Cretaceous. Minutes, not months. Every other chapter of this video has been slow. Hours to a day. A tide. A clock that runs for months and stands for millennia. This one is different, in a way that makes it feel almost merciful by comparison, until you get to the end of it. 66 million years ago, an object about 14 kilometers across hit the shallow sea over what is now the Yucatan Peninsula at roughly 12 kilometers per second. The energy released was on the order of 300 sextillion joules. If that number means nothing to you, and it should mean nothing to you, it is roughly 5 billion Hiroshima bombs. The crater is called Chicxulub, pronounced Chicxulub. In the first seconds, the impact opened a cavity about 28 kilometers deep. Then, within minutes, that cavity collapsed under its own weight into a crater around 3 kilometers deep, and the floor rebounded into a ring of peaks. 28 kilometers to 3 in the time it takes to microwave a burrito. Now, where are you standing? Because in this chapter, distance is the entire story. If you are anywhere near the Gulf, there is nothing to narrate. About 2.5 minutes after contact, a rim wave roughly 4.5 kilometers high is moving away from the crater. Along the shores of the Gulf, waves 50 to 300 meters high come ashore and push perhaps 100 kilometers inland. Call that a regional erasure rather than a coastline event. So let us put you 3,000 kilometers away, in what is now North Dakota, on the edge of the inland sea that split North America down the middle at the time. It is a normal day. You feel a flash on the horizon, more sensed than seen. 10 to 30 minutes later, depending on which seismic waves you count from, the ground moves. The impact released the seismic energy of a magnitude 10 to 11 earthquake, and those waves crossed the continent faster than any wave in the water could. The inland sea, all of it, sloshes. This is a seiche, pronounced seiche. The standing wave you get in a bathtub during an earthquake, except the bathtub is a sea. Water about 10 meters high, call it 30 feet, comes up the river valley against the flow. The site where this is recorded is called Tanis, and it was described in 2019 by a team including Robert De Palma, Mark Richards, and Jan Smit. In that deposit are freshwater fish, sturgeon and paddlefish, packed together with tiny glass spherules lodged in their gills. Those spherules are droplets of molten rock ejected from the crater, cooled into glass on the way up, and rained down 3,000 kilometers away while the fish were still breathing. They breathed glass, and after that the wave came. Now, in fairness, Tanis is a site where a lot of the specifics are still argued over, from the season of the impact to the exact sequence of events, and you should know that going in. But the broad picture, seismic waves first and water second and glass falling through all of it, is what the published work describes. And you are on that riverbank, so the wave is your death most likely. But suppose it isn't. Suppose you are on high ground and the water does not reach you. Then look up, because the sky is about to change. All that material thrown out of the crater goes up on ballistic arcs, out of the atmosphere, and comes back down all over the planet at once. Re-entering, it heats the upper atmosphere until the entire sky is glowing. For something like an hour, the surface of the Earth is under an oven set to broil. This was no fireball at the horizon. The sky itself, everywhere, radiating down. Anything on open ground and not underground or underwater takes that heat directly, and widespread fires follow. So the order in this chapter is flash, then ground wave, then the sky heats, physics arriving in order of how fast each thing travels. And if you were sheltered in a burrow or a cave or under deep water, and you came out an hour later into the smoke, that is where the fifth extinction turns back into the other four. Because the fires and the pulverized rock put soot and dust into the atmosphere, and the sunlight went away for years. Gone, or nearly gone. Photosynthesis crashed on land and in the sea. The temperature dropped, and what kills you now is what killed you in Chapter 1. Cold and dark, and nothing growing, stretched over months. Your body handles that the way it handled the Ordovician coast, only slower, because this time you can build a fire and the fuel is everywhere. What you cannot do is grow food, and neither can anything you might have eaten. The fire keeps you warm while you starve. About 75% of species were gone by the end of it. The dinosaurs get the headline, but they were the last minutes of a story that ended slowly. So there it is, 5 chapters. Cold on an empty coast, poison off the shallows, a clock that ran everything at once, the same clock again, and a sky that cooked the ground before it went out. 5 ways a planet clears the board without a single predator involved. Now, which one did I leave off? Go back to the count. Ordovician, Devonian, Permian, Triassic, Cretaceous. That is the big 5, and it is a real list, and it is complete as far as the rock record goes. But there is a 6th candidate that does not show up in the rock yet, because it has not finished. It is happening now. Let me give you the numbers, and I will be careful with them, because this is a place where sloppy numbers do real damage. The background rate of extinction, the pace at which species disappear when nothing unusual is happening, is estimated at roughly 0.1 to 1 species lost per million species years. A more conservative estimate built from mammals puts it around 2. Against that, current extinction rates are estimated at 100 to 1,000 times background, with projections pointing toward 10,000 times if trends continue. In 2019, the United Nations Biodiversity Assessment concluded that around 1 million species are threatened with extinction within decades, and a 2023 study led by Gerardo Ceballos counted 73 genera of vertebrates, not species, whole genera, lost since the year 1500, a loss that would have taken about 18,000 years to happen at background rates. Now the honesty ledger, because you have earned it. A mass extinction is usually defined as something like 75% of all species lost within a window of under about 2.8 million years. By that definition, we are not there, and whether we are on track to get there depends partly on the true background rate, which is itself uncertain, and scientists disagree about whether the label fits yet. That disagreement is real. What nobody disputes is the rate. It is far above anything normal, and it is being driven by one species. That part is measurement, and nobody is arguing it. So put yourself in the sixth one, the way you did in the other five. You are standing there. Except this time there is no ice sheet at your back, and no sulphide off the shallows, and no glowing sky. There is a parking lot, and it is a Tuesday, and nothing about the air or the water or the sky is going to read as a warning. That is the difference in scale. In every other chapter, the mechanism was something happening to you. This chapter has a witness who can read the rock and count the genera and run the numbers on the rate, and that witness is not standing outside the mechanism. The witness is the mechanism. If you want the next one, where I walk through what the recovery looked like after each of these and how long it took the planet to rebuild from each of the five, that video is on screen. Same voice, same rules, disputed parts flagged. Go watch it.